Okay, so in the last lecture, we have seen the case where the auxiliary equation had real roots which were distinct, and in the second case, we saw that the roots were repeated roots. In this lecture, we are going to discuss about the case where the roots are complex. So let me write imaginary or complex roots of the auxiliary equation. So suppose Fm equal to 0. This Fm equal to 0 is called what? It is called auxiliary equation. Has complex roots alpha plus minus I beta. Okay. Then what I will do is I will call the first root M1 is alpha plus I beta, and I will call the second root M2, which is alpha minus I beta. Then what is the general solution? So if you have M1 and M2, now alpha plus I beta and alpha minus I beta. So beta is, I am saying that beta is, suppose for some time, let's say that now this beta has to be not equal to 0, because if beta becomes 0, then the roots will be real roots, because in that case you will just be left with what? You will be just left with alpha, and alpha is a real root. So real ka to humne already we have seen the case of that. So the point in this thing is that this beta should not be equal to 0, otherwise they will become real roots again, right? And alpha is a real number and beta is also real number. Now if this is the case, then I know that if m1 and m2 are roots, then what is the general solution written as? So if m1 and m2 are roots of auxiliary equation, so because we have written that the roots are m1 and m2, if m1 and m2 are roots, then the general solution is of the form y equal to c1 e raised to m1x plus c2 e raised to m2x. Therefore y is equal to c1 e raised to, what is m1? M1 is alpha plus I beta x plus c2 e raised to alpha minus I beta x, which is equal to c1 e raised to alpha x into e raised to I beta x plus c2 e raised to alpha x into e raised to minus I beta x. Correct. But we know that e raised to I theta, this is called Euler's formula, is cos theta plus I sin theta. So this will be equal to y equal to c1 e raised to alpha x into cos beta x plus I sin beta x. So the value of theta here is now, theta is replaced by what? Beta x plus c2 e raised to alpha x into, what is e raised to minus theta I theta? E raised to minus I theta is what? Plus minus is cos theta minus I sin theta. So it is equal to cos beta x minus I sin beta x. which is equal to, now I will pull out, I can pull out e power alpha x common. So if I pull out e power alpha x common, what will I get? I can even put e power alpha x into cos beta x. See, here I can pull out these two things common. So e power alpha x cos beta x. So what is there inside now? C1 plus C2 plus, I can even put e power alpha x into sine beta x. So what will I be remaining with? I'll be remaining with IC1, correct, and minus IC2. But C1, C2 are all constants. So I will just replace the C1 and C2 by some constant. Suppose I'm calling it C3, and if I replace this constant by some C4, this will look like y equal to C3 e power alpha x cos beta x plus C4 e power alpha x sine beta x, where C3 and C4 are constants. Okay, so this now becomes the general solution if the roots are complex. Okay, if the roots are complex type of roots. So let us take one example so that the concept will be very much clear to you. Okay, so let me take an example. Now let us take a quadratic equation which has complex roots. So in my mind, the roots should be 2 plus minus 3i. So what is that quadratic equation which has the roots 2 plus 3i and 2 minus 3i? That quadratic equation is actually m square minus m plus something equal to 0. So what should I write here and what should I write here? Okay, so here we know that we have sum of the roots, isn't it? Sum of the roots is what? 2 plus 3i and 2 minus 3i is how much? Just 4. And here you write the product of the roots. What is 2 plus 3i multiplied by 2 minus 3i? It is 2 square plus 3 square. So 2 square plus 3 square is 14. 9 plus 13, sorry, 13. So I will prepare this type of question. So what should I write as? Solve the differential equation. What should be my question? I hope you got my thing now. It is d2y by dx square minus 4m 4 dy by dx plus 13y equal to 0. I want to find the general solution of this differential equation. So solution, so here fm is equal to, so what is fd equal to, or let me write it like this, d square minus 4d plus 13y is equal to 0, and therefore what is fm equal to from this? Fm is equal to m square minus 4m plus 13 equal to 0. This is called as the auxiliary equation. And what are the roots of this auxiliary equation? M is equal to minus b plus or minus root b square minus 4 ac upon 2a. Okay, and now when I solve this this thing, it will actually reduce to how much? 2 plus or minus root of this will be minus 9 into something. I will write it directly 3i. Okay, और ये नीचे का ये जो 2 है वो cancel हो जाएगा. So I know, I'm sure that this will simplify to 2 plus or minus 3i. So this is of the form alpha plus I beta plus or minus I beta. And what is the value of alpha? Alpha is 2 and beta is 3. So the roots are complex. And therefore, what is the general solution given by? General solution is C1 e raised to alpha x cos beta x plus C2 e raised to alpha x sine beta x. Now, in the actual, when we were actually doing the above things, okay, we had written there what? We had written that there C3 and C4, but it is okay. I will now call the new constants as what? C1 and C2. So what is the solution? So this is y equal to C1 e raised to 2x cos 3x plus C2 e raised to 2x sine 3x. So this becomes the general solution of the differential equation, where the auxiliary equation had what? Auxiliary equation had complex roots. Okay, let me take one more example now. So solve d2y by dx square plus 4y equal to 0. I want which type of roots? I want complex roots. Do I get complex roots? Let me just check. Okay, solution d square y plus 4y is equal to 0. So d square plus 4 is equal to y 0. So this is fd. So what is fm from this? Just replace d by m. So fm equal to m square plus 4 equal to 0. So this will become your auxiliary equation. So what is the solution of m square plus 4? This is m square equal to minus 4. So m is equal to plus or minus square root of minus 4. What is the square root of minus 4? The square root of 4 is 2. So square root of 4 is 2 and square root of minus 1 is I. So m is equal to plus or minus 2i. So this means that this m is actually of the form 0 plus or minus 2i. So here alpha is 0 and beta is how much? Beta is 2. Okay. So therefore, what is the general solution given by? I'll write the formula again. C1 e raised to alpha x cos beta x plus C2 e raised to alpha x sine beta x. We know that e raised to 0 is how much? 1. So this will become, this e raised to 0 will become 1. This will also become 1. So my general solution will remain C1 cos 2x plus C2 sine 2x. This becomes your general solution. Usually when you are solving the simple pendulum equation in physics, okay, it often comes out to be this type of differential equation, d2y by dx square plus omega square y equal to 0. Okay, this usually this differential equation arises when you're solving the simple pendulum differential equation. Okay, simple pendulum problem. So we know that the simple pendulum problem has what type of solution? What is the solution? It's an oscillatory motion, right? So mathematically, how will you prove that it is an oscillatory motion? So we will solve this differential equation and we will show that the solution of this differential equation has terms which are oscillating. Now, what are the terms that are oscillating or periodic functions? They are sine and cos. So this differential equation must also have solution which involves sine and cos. Okay. So this means that it is d square plus omega square y. We are going to prove it now. Okay, so let us go through it. So it is 0. So this is fd. So what is fm? Fm is equal to m square plus omega square equal to 0. So this means that m square is minus omega square, and therefore m is equal to plus or minus omega I. So this is nothing but your of the form alpha plus or minus I beta. So it is 0 plus or minus omega I. So the value of alpha here is 0 and the value of beta here is how much? Omega. So here, therefore my solution will become y is equal to c1 e power alpha x plus cos beta x plus c2 e power alpha x sine beta x, which is equal to, so I again know that e power 0 is how much? 1. So this is equal to c1 cos omega x plus c2 sine omega x. So this becomes the general solution of the simple pendulum problem. So we observe that, as expected, this equation has two terms, cos and sine, which are periodic functions, and that is why when the pendulum moves, we say that it is a periodic motion, or you say that it's oscillatory motion. So it will repeat its nature after the same time, because sine function and cos function have the same property, that they repeat after a period of how much? After a period of 2 pi. Okay, so this is how you adjust the mathematics inside your physical problems. Now often you must have seen that sometimes it happens that when the pendulum is moving, we see that after a long period of time, what happens? The pendulum eventually stops the motion, correct? It doesn't remain oscillating forever, right? That ideal condition is usually not possible. It means people of physics call it something like dissipation. So there is dissipation, or because of the air resistance, the pendulum eventually has to stop. Okay, so in that case, what should happen is, now here you see that now only the thing is that in physics what you do is, when you write the equation, when you write the differential equation, you write d2y by dt square. So here t is playing the role. T is your time. So I'm writing it in the form of with respect to time. So what does t denotes? T denotes the time. So if t denotes time, what will be the solution? The solution will be what? C1 cos omega t plus C2 sine omega t. So if t tends to infinity, if t is varying from 0 to infinity, okay, what will happen? This will, cos will keep on oscillating. Sine is also keeping on oscillating. Means this, no matter how large t is, this equation is trying to tell us that the pendulum will remain oscillating. Okay, but we know that physically this is not possible. Slowly what should happen? The motion of the, so this is a time axis and this is a y. What should happen? The pendulum should slowly reduce down the motion. Means that if the pendulum oscillation, if I'm counting, what should happen? It should happen that the motion धीरे धीरे उसका amplitude क्या होना चाहिए? कम होना चाहिए. It should become like this, and eventually the displacement stops. This is the displacement. Okay, I'm counting from the positive side, negative side. Okay, so this is our actual physical situation of the pendulum. Now if I want to get this type of solution, what should the differential equation be? What is a possible differential equation which will give me this type of solution, right? Now if I take a differential equation, I want to construct a differential equation which has roots which has roots -1 plus -1i. So what should be the differential equation now? I hope you must have got this. So this should be of this form. And here I must have the sum of the roots. The sum of the roots is -1 plus I and -1 minus I. So I and I get cancelled. So I will get a -2 here. And in the constant term, I must have the product of the roots. Now what is the product of -1 plus I and -1 minus I? The product of two terms is 1 square, 1 square, which is -1 square plus 1 square. What is -1 square plus 1 square? It is 2. So this must be my auxiliary equation. So what is the differential equation now? I'm going to give you, I'm going to say solve d2y by dx square plus 2 dy by dx plus 2 is equal to 0. So now we'll write it in the D format. So what is it? It's capital D square plus 2D plus 2y equal to 0. And that will give me, what is the auxiliary equation now? It is m square plus 2m plus 2 equal to 0. And I will solve this quadratic equation by my formula. M is equal to -2 plus or minus root b square minus 4ac by 2 times a, which is equal to -2 plus or minus 4 minus 8 is -4 divided by 2, which will give me -2 plus or minus 2i divided by 2. So this finally comes out to be -1 plus or minus I, which I was expecting. And this is of the form alpha plus or minus I beta. So the value of alpha is -1 and beta is equal to 1. Okay, and therefore what is the general solution? Therefore the general solution is given by what? The general solution is y is equal to c1 e power alpha x plus cos x plus c2 e power alpha x sine beta x, which is equal to y c1 e power minus x cos x plus c2 e power minus x sine x. Okay, so this is the general solution of the differential equation that we have taken. Right, now let me put it in the terms of displacement and time. Okay, if I write the same differential equation as d2y by dt square plus how much it was? It was how much? 2 dy by dt plus 2, I forgot a y over here, so there's a y here, plus 2 dy by dx, plus 2 dy by dt plus 2y is equal to 0. Now here y, instead of being a function of x, here y was a function of x in this problem. Here now y is a function of time. So this will give me, what is the solution? Y is equal to c1 e raised to how much? E raised to minus t cos t plus c2 e raised to minus t sin t. Okay, so here the terms involved are e raised to minus t sin t and e raised to minus t cos t. And now when I try to draw the picture, okay, I will also teach you in my future lectures of how to draw the picture that I'm showing you. Okay, so that you will now really understand or get a feel that how a differential equation really tells you that this kind of pendulum is eventually going to stop mathematically. Okay, physically we know that it has to stop because of air resistance and many factors are there. Okay, now what happens as t tends to infinity? What happens as t tends to infinity? Do you observe that as t tends to t tends to infinity, what happens to e raised to minus t? What happens to this person? This person is as good as e raised to t, correct? if t is tending to infinity, the exponential function is also tending to infinity. If t tends to infinity, exponential also tends to infinity, and therefore the reciprocal will tend to what? Therefore the reciprocal will eventually tend to 0. Okay, and what about cos t? So I know that as t tends to infinity, what I'm trying to tell you is that e raised to minus t tends to 0. And what about cos and sine? Cos and sine function भी है ना? So cos and sine, they will oscillate. So they will keep on oscillating between what? What does cos and sine oscillate between? Cos t and sine t oscillate between -1 and 1. Correct. So imagine a particle is oscillating between -1 and 1, but at the same time there is one factor which is taking it close to 0. Okay, if you look at this picture that I'm drawing now, this is oscillating. It is not going to, it is not the displacement. The y is displacement. This is time axis. The displacement is not the displacement is not tending to 0. It is remaining, it is oscillating between 1 and -1, like sine or cos. Okay, this is general. I'm here, the figure I draw just now was about sine. We have to draw a combination of sine and cos. Okay, so it should look like, so this equation tells me that the motion should be what? It should be oscillating also because of sine and cos. Not only oscillating, it should, because of e raised to minus t, it should also dissipate, or the amplitude or the displacement should slowly reduce to 0. That is, amplitude should go on decreasing because of this e power minus t. So how will the curve look like if I try to draw this? I will teach you one small software in which we will be able to draw such type of graphs, and then we'll actually see the solutions of this differential equation. Okay, so it will oscillate because of the oscillatory function, but as the time is धीरे धीरे time जैसे बढ़ रहा है, जैसे time increase हो रहा है, what is going to happen? This entire combination is going to what? This entire combination will go to 0. So मैं picture निकालते वक्त I will draw it like this, like this, like this, like this, like this. Okay, so now this is the actual physical pendulum problem. Okay, so to understand this picture, to draw this picture, to come up to this picture, what is important? You should know the theory of your differential equations. You must know how to handle real roots, complex roots, what are the general solutions. Then after some days we will take a particular problem, we will take a particular time, that at this time the pendulum is at this position and the differential equation which determines that motion is this. Then what is the position of the particle at 100 after 100 seconds? We will be able to determine that using our mathematics part also. Okay, and we will use all this theory. Okay, so I hope the crux of the lecture is understood. The crux of the lecture was only this much, that if you have complex roots, then the general solution is always of the form c1 e power alpha x plus c2 e power cos beta x and c2 e power alpha x sin beta x. Okay, now let us take the next problem. Find the general solution of d3y by dx cube minus 2d y by dx plus 4y equal to 0. So let us see how to solve this. So what is the auxiliary equation here? The auxiliary equation is d cube minus 2d plus 4 is equal to 0. So which I will say m cube, which you write it as in the form of fm, which is m cube minus 2m plus 4 equal to 0. Right, now this is a cubic equation. What is the constant term? The constant term is 4. So what are the factors of constant term? Look at the factors of constant term. Plus minus 1 is a factor, plus minus 2 is a factor, and plus minus 4 is the factor. So this cubic equation, I want to factorize it. Now what we know about any cubic equation is that it must have at least one root. So cubic equation must have at least one real root. Which cubic equation? The with the coefficients must be real. Coefficients real. So who are the coefficients? The coefficients are 1, 2, minus 2, whatever, and 4. So all the coefficients are real. So this means that this is a very standard result. So this odd degree polynomial with real coefficients must have at least one real root. What is the odd degree? Third degree. It's a cubic polynomial. So then I'm sure that this cubic equation will have a real root. So I'm trying to find the first root by my guess. So if you put 1 and minus 1 in this equation orally, you will see that it is not becoming equal to 0. So I forget about 1. Can I try for 2? If I try m equal to 2, you get 8 minus 4 plus 4, and that is not equal to 0 because it is 8, right? So 2 is a bad choice. Let me try for m equal to minus 2. If I put m equal to minus 2, I will get minus 8 plus 4 plus 4, and that is becoming perfectly 0. So this means that m equal to minus 2 is a root of which equation? Of the equation m cube minus 2m plus 4 equal to 0. So now the next two roots. So out of the three roots, we have found out two roots. Sorry, one root. So how will I find the next two roots? I will use the synthetic division. So synthetic division, I need to find all the coefficients here. The first coefficient of m cube is 1. The second coefficient of m square coefficient is 0. So this is coefficient of m square, which is absent here. Then I have a minus 2 and then I have a 4. I perform synthetic division. I'm going to put a minus 2 here, which is the root. So I will get 1 is carried out this, and minus 2 into 1 is minus 2. This is minus 2. I added them, added this and this. Again, minus 2 into minus 2 is 4. Minus 2 and plus 4 will become plus 2. And minus 2 into plus 2 becomes minus 4. And this must come to be 0 because it is a root. So we get, from this we get 1m square. The quadratic equation from here is minus 2m plus 2 equal to 0. And now I will factorize this particular quadratic equation. Now you understand that this you cannot factorize, you cannot find the real roots. So I will use the quadratic formula. I will write here cannot factorize real factors. Okay, I'm not able to get real factors. No real factors. So I will use my formula minus b plus or minus square root of b square minus 4 ac upon twice a. It is 2 plus or minus square root 4 minus 8 upon 2, which is 2 plus or minus square root of minus 4, which is 2 plus or minus 2. Square root of 4 is 2, minus 1 is I divided by 2. So this means that m finally becomes 1 plus minus I. So these are the two complex roots. So what is the first root? The first root was real root, which was minus 2. We have written above. The second complex root is 1 plus I. The third complex root is 1 minus I. So we got all the three roots of cubic equation. And now we will write the general solution. So this is a real root. So we know what is the format for the general solution. It is C1 e raised to m1, that is minus 2x plus. For this complex pair, I know that alpha is 1 and beta is also 1 because it is 1 plus 1i. So alpha plus beta I. Okay, so beta is how much? Beta is 1, alpha is also 1. So what is the solution in this case? C2 e raised to alpha x. Who is alpha? C2 e raised to 1x cos 1x plus C3 e raised to 1x sin 1x. Finally the solution. I will omit this ones here. Is C1 e power minus 2x plus C2 e power x cos x plus C3 e power x sin x. So this becomes the general solution, which has real roots and complex. The auxiliary equation had real roots and complex root at the same time. Okay, let's try one more example now. Solve t square plus 1 square y equal to 0. So clearly here this is fd. So fd is t square plus 1 whole square. What is fm? So what is the auxiliary equation? The auxiliary equation is fm equal to m square plus 1 whole square equal to 0. So this means that m square plus 1 is 0 is twice, 2 times. What is m square plus 1 equal to 0? This means m square is minus 1, m square is minus 1. So this means m is plus minus square root of minus 1. M is plus minus square root of minus 1. And this is m is equal to plus minus I. And m is equal to plus minus I. This means that we have 4 roots. What are the 4 roots? The 4 roots are I repeated minus I minus I. So we have repeated complex roots. Repeated complex roots. Okay, what are they? So 0 plus minus I, let me write 1i, 0 plus minus I. So this complex roots are repeated twice. So this complex root 0 plus minus I is repeated twice. Now what will be the general solution? So I know that alpha is 0 and beta is 1. So what is the general solution of such type of thing? Now usually when the root is not repeated, suppose this is not there. So what is the formula in that case? We write c1 e power alpha x cos x cos beta x plus c2 e power alpha x sine beta x. But if it is twice, I will simply add plus c3 e power alpha x cos x cos beta x plus c4 e power alpha x sine beta x. This is the same thing which we have used in the real roots also. When we had repeated roots, we inserted x, x square, x cube and so on. So here also we will use the same thing and this works. Eventually this all is correct. This works. We are not justifying this right now. So what will be the solution of our problem now? Let us put alpha equal to 0 and beta equal to 1. So I'm getting c1 cos x plus c2 sin x plus c3 x cos x plus c4 x sin x, which henceforward we will remember not to write so big, but we will just collect the cos and sine terms together. So we will write c1 plus c3x cos x plus c2 plus c4x sin x. So this will be easy to, so whenever the root is repeated, you just insert the x in the constants. And the format is the same, cos x and sin x. E power 0x is not there. That is why it looks so simple. So in general, what am I trying to tell you? In general, if alpha plus or minus I beta is repeated twice, let's write it a note here. It's repeated twice. Then what is the solution given by y equal to e power alpha x c1 plus c2x. Now I'm using c2 here only. If I call it c3, c2, it doesn't matter. Cos x plus e power alpha x c3 plus c4x sine beta x. So this will be the general formula for a auxiliary equation with repeated complex roots twice. Okay, had it been thrice, I would have done the same story. I'll just write half part of it. So it will be just e power alpha x c1 plus c2x plus c3x square cos beta x, and similarly the part for sine will also come. c4 plus c5x plus c6x square sine beta x. So repeated thrice. So the story will continue. Okay, let's take one more problem. Exercise. d raised to 4 plus 10 d square plus 9y equal to 0. Let us see what is this now. Solution. So what is your FD is d power 4 plus 10d square plus 9 Fm is m raised to 4 plus 10m square plus 9 equal to 0. If you can see this, like suppose I put a simple substitution as m square is equal to say x, what will this look like? Now what is x? This x and dy by dx should not, let me say p. This will look like p raised to 4 p square plus 10p plus 1 plus 9, which I can actually factorize at p plus 9 and p plus 1, correct? So this means that this is actually m square plus 9 m square plus 1 equal to 0, right? And then when I write the separate these factors, I will get m square is equal to minus 9 and m square is equal to minus 1. So m is equal to square root of minus 9 is plus minus 3i. Here I'll get m square root of minus 1 plus minus is I. So I got roots where here the roots are 0 plus minus 3i, and here I got m is equal to 0 plus minus 1i. So here alpha is 0, beta is 3, here alpha is 0 and beta is 1. So I got 4 roots, and all the 4 roots are distinct, no repeated roots. For this particular part, we have our standard formula e raised to alpha x cos beta x sin beta x. For this part also we have a standard formula, same. So what will be the solution in that case? Y equal to e raised to 0 will be 1. So I will not write that e raised to alpha x part. Okay, so what will be my solution in this case? It will be y equal to c1 cos 3x plus c2 sin 3x plus, this is for the first part, and this is c1 cos x because beta is 1 plus, sorry, not c1, I have c1 c2 used, so I'll write c3 cos x plus c4 sin x. So these will be the, this will be the final answer. Because everything was good, life was easy because the roots were distinct roots. For instance, if I take this particular example, d raised to 4, I'm going for the 4th degree polynomials, okay, plus 8d square plus 16y is equal to 0. Right? Do you observe the difference between the previous problems and this problem? In the problem where we were having a cubic equation, there I had told you that you must have at least one real root. But do you observe that that theorem is not true for the 4th degree polynomial? A 4th degree polynomial may have all roots complex. See, all the 4 roots were complex roots. So any odd degree polynomial, whenever you are getting any odd degree polynomial with real coefficients, coefficients should be real, then you can always guarantee that you must get one real root. Okay. Okay, this important fact is sometimes used when you are solving some problems on numerical analysis. In numerical analysis, in the course of numerical analysis, you have to sometimes find the root of some cubic equation using Newton-Raphson method. There are different methods. And then you make a guess. Suppose I start with the initial guess is 1. The question should be asked over there is that how do you guarantee that a real root will exist? So why that is true? Why can you do it over there? Because it's an odd degree polynomial, and any odd degree polynomial has at least one roots. Therefore, I will start with the initial guess as a real root, and then I will start solving. Okay, so the result is not true for polynomials which are having even degrees. For odd degrees, it is always true, but the coefficients must be real coefficients. Now this is a 4th degree polynomial, this we are looking at right now. So I don't guarantee that it may have real roots, it may not have real roots. Well, can I handle this now? So what is fd here? It is d power 4 plus 8 d square plus 16, and therefore what is my fm is m raised to 4 plus 8m square plus 16. And I again see that if I put m square equal to x or m square equal to p, this will look like what? This will look like p square plus 8p plus 16 is equal to 0, and this is simply factorization of what? This is factorization of p square p plus 4 whole square is equal to 0. What is p? What is p? P is m square. So this is m square plus 4 whole square is equal to 0, and therefore this means that this is m square plus 4 equal to 0, and m square plus 4 equal to 0 two times. And this has m square equal to minus 4, which is giving me eventually m is equal to plus minus 2i. Similarly, here I will get m equal to plus minus 2i. So I see that this root m equal to 0 plus minus 2i is a complex repeated root twice. Root, and how many times it is repeated? It is repeated 2 times, and therefore we have seen what is the general solution. I hope I have to go back and see what is the general solution for that. If you have repeated complex root, you write the solution in this particular format. You just have to make x, add x in the constants. Add means attach, which I'm saying e raised to 0x, which is alpha is 0 and beta is 2. So I don't need to write this e raised to 0x. I'll write c1 plus c2 x cos 2x plus c3 plus c4 x sine 2x. So this becomes the solution of this particular differential equation that we have taken. Okay.